can see it turns into a ball really fast. Can you see the ball sitting there? And you can hear it hissing. And the hydrogen gas is going to light on fire when it gets hot enough. Can you guys see the sodium in there? You know, do I have it too low? Darn it. Do this. Keep going, buddy. Did that help at all? And you can see there's so much steam in there that it's hard to see the little silver ball now. I mean, it's almost gone anyway. So I'm going to put another piece in. Oh, geez. That lends itself to another. This is a very soft metal. If I can cut it with basically a butter knife, it's pretty soft metal, right? I'll put this piece in. Still kind of smoky in there. When it lights on fire, you'll be able to see it better. It blew itself out on purpose. There it is. I'm going to add some, keep going, Claudia. I'm going to add some phenolphthalein in there now. And what's that indicating? It's a base. There's sodium hydroxide present. Okay, Claudia.
Now that you've seen the chemical reaction happen in the beaker, it's time to talk about the chemical equation that represents what happens in the beaker. What you saw was a single replacement reaction between sodium and water. Here is a single replacement reaction. The flames that you saw were the hydrogen gas burning. Possibly the popping you heard was the hydrogen gas burning. And sodium hydroxide in water is a base, and so that's what turned the phenolphthalein pink. Here's our unbalanced chemical reaction between sodium and water. This is called a single replacement reaction because the sodium is kicking out one of the hydrogens to make sodium hydroxide, and the hydrogens that get kicked out are banding together to form H2. These pictures represent what you see above. So this is a sodium atom, this is a water molecule, this is a hydrogen molecule H2, and this is supposed to represent sodium hydroxide. These should be linked, and NaOH. So the equation is unbalanced the way it's written. It's violating the law of conservation of matter. I have two hydrogens here, but over here I have two hydrogens and another one over there. So I need to make that work. To make that work, I'm going to start off with a 2 here. And I'm going to represent those in pictures. There's a sodium and there's the hydroxide. So now we have 2 sodium hydroxides. Because we have 2 yellow sodiums here, I better have 2 yellow sodiums here. So I'm going to put a 2 there and represent that with a model. So now I have 2 yellows and 2 yellows, 2 sodiums and 2 sodiums. So this 2 represents 2 different sodium atoms. This 2 represents 2 different sodium hydroxide molecules. Well, now let's take a look at the hydrogen. I have 2 there, and now I have 2 more here. If you don't believe me, I have 2 white ones there and 2 white ones here. That makes 4. I need to have 4 white ones here. I need to put a 2 here. And I need to add that molecule. This is our balanced chemical reaction in which we have the same number of atoms on each side. We have 2 sodiums and 2 sodiums, 4 hydrogen, and there's 2 hydrogen, and there's 2 more hidden over here, hydrogen. And then the oxygens, we have 2 and 2. So there is our balanced chemical reaction or equation. This is the equation. The reaction is what happened in the beaker.